to a couple of examples from 14. So I'm going to do 14A and D. So the thing to realize here is that whereas in 13 the quantified expression was like all ravens or 5 pies, in here it's going to be there's relative clauses. So in A it's going to be every book that Marissa read is the full quantified NP. So let me show you the picture. All right. So what you need to do here is remember the how we did the lambda expressions for relative clauses. So you have an S bar for that Marissa read, which I hope you remember, is lambda x read Marissa x, right? Because we have the subject, it's just that the object of what she's read is relativized, okay? And then we have book, which is lambda x book x, and at this n bar constituent up here, we're combining the predicates of the relative clause and book. So we have a lambda x that is a book and that was read by Marissa. And then every, it's the same as in the previous examples. This is the denotation of every. So then the first one place predicate that every is combining with is this full n bar, right? So even though it's a complex predicate and it has 2 parts, it's still just a one-place predicate because it just has a single lambda x expression. Okay, so we combine that with every, and it plugs in for the lambda f of every. So the denotation of this NP node is lambda g, and then this set that is X's and is read by Marissa, okay, which is books that Marissa read, right? It's a predicate that is something that is a book and that was read by Marissa. And so we're still looking for the other predicate that every is going to take, all right? And so that is going to be the VP node. So these are the denotations for and was. And so both of these are essentially identity operations. So we have, so the sentence is every book that Marissa read was a thriller. So thriller, the predicate over here is lambda x thriller x. At the NP2 node, it's lambda x thriller x, right? Nothing is changing over here. And then at the VP node, lambda x thriller x. And so here I have, I had the G predicate. So we have every is looking for a lambda f and a lambda g. I had the, which are both one-place predicates, as we talked about in the last screencast. So what I did here is I broke down a little bit what happens when the VP predicate gets plugged in. So first I'm plugging it in for G, and then I have Y filling in where the X is and canceling out the lambda X. You don't need to write out this step. We typically skip it over, but Kearns has it shown, and so I wanted to show it for one of the examples. And so the thriller predicate is the other predicate that every is looking for. So thriller, the VP predicate, is filling in for the lambda G, the G predicate that every is looking for. And of course, over here we had book that Marissa read filling in for the lambda F predicate. So what this means then, the denotation of the full sentence, is that the set of things that are books and that Marissa read them are a subset of things that are thrillers. Okay, and that's what that sentence means, right? Every book that Marissa read was a thriller. So let's move on now to 14D. Ramon signs every sculpture he makes, which is a little bit more complicated. I have it done in 2 parts. So here's the first one. Oops, let's zoom in. Okay. So I have this split into 2 parts. I haven't shown the object undergoing quantifier raising at this point. So I have the S bar that he makes as a lambda x, right? This I hope is familiar. And then this is lambda x make Rx. We know that he is co-indexed with Ramon. That's just something we're taking for granted. So you can just plug in the R for the subject of make. And then we have sculpture, lambda x sculpture x, and then we do the same thing that we did in the previous example and that we had been doing for relative clauses in lambdas. So we combine this predicate with this predicate into another predicate, but still just a one place. So we have a lambda x make rx and sculpture x. So these are obviously sculptures. This is referring to sculptures that Ramon makes. And then we have the denotation of every again, and we plug in this predicate, this lambda x predicate for lambda f. So we have the set of things now that are made by Ramon and that are sculptures, all right? That's the first predicate, the lambda f, all right, the f predicate that every is looking for. Okay, but then we have to do the g predicate, which is a little bit more complicated. So this whole thing is going to move, is going to undergo quantifier raising. So what's going to undergo quantifier raising is this every sculpture he makes constituent. And I want you to note that this is what's called a headless relative. So this would be no different from every sculpture that he makes, but there isn't a that here. It's null, okay? But the structure is still the same whether or not the that is present. Okay. All right, so here is the second part of this one where things get a little interesting. So this is like we saw for the Jones 8-5 pies example. What is happening is that this NP, every sculpture he makes that started out in object position, undergoes quantifier raising and raises to this higher position up here. And what we are left with down here is this x prime constituent, which is basically the trace. So where the every sculpture he makes, where it moved from. Okay, so we have this NP1, right, which I copied over from the previous, from the bottom of the previous page. And now we have, so the verb signs is a two-place verb, right? Lambda y, lambda x, sign xy. It's a two-place predicate. And then so the VP is what's going to happen is that the lambda y is going to be filled in by this x prime constituent. So even though it's like it doesn't have any real content at this point, since the actual content has moved up here, we're still plugging it in for a lambda y. So it's behaving as a type E entity for the purposes of the sine lambda expression. So then the VP is lambda x sine x x prime. And then we move up here and we plug in Ramon for the subject position within sine. So we have sine r x prime. And this, like I said for the Jones 8-5 pies example, this is now looks like it should have a truth value, right? Because there are no lambda expressions remaining. We've saturated both of the arguments of sine, and it's no longer an unsaturated predicate. It's fully saturated. But so now what we do is we add these other projections like we did for Jones 8-5 pies. We have this lambdacizer, this predicaticizer projection, and what that's going to do is it's going to take the output at the S3 node and turn it back into a one-place predicate, all right? And remember, so anything that just has a lambda x in front of it, that you can just look at it for a split second and know that that's a one-place predicate, right? And this one-place predicate is it's basically something that Ramon signed, all right? Since it's the object position that has the lambda around it. Now we go up to the top S1 node, and remember we've already filled in the lambda f of every with so something that Ramon makes and is a sculpture. And now we take this expression, this lambda expression, and fill it in for the lambda g, for the other one-place predicate that every is looking for. So what we have is So the set of things that Ramon makes and that are sculptures are a subset of everything that Ramon signs. Okay. I hope that makes sense. I know that this is combining some elements from different units. So we're combining what we learned in the generalized quantifier section with what we learned from the chapter 4 expression on lambda, but it's not really new material. It's just combining it in a way that makes full use um, of all of the skills that you have acquired and that you've learned about how to represent quantifiers in terms of set relations and also lambda expressions. Okay, thanks.